Hello, ladies and gentlemen. Today's topic is using the Pythagorean theorem in two dimensions. And our objective is I can apply an understanding of the Pythagorean theorem to right triangles in two dimensions. So that means like on a flat piece of paper. We're not talking about any three-dimensional cones or anything like that using the Pythagorean theorem there, although we will be doing that in the next couple days. Right now, we're just dealing with plain old simple right triangles and the Pythagorean theorem. So from class today, we learned that the Pythagorean theorem is a squared plus b squared equals c squared. And we did that little thing where we took the triangle and made the squares on all the sides and saw that the square of the two smaller sides equals the square of the third longer side called the hypotenuse. So A and B are the legs of a right triangle. So here's a right triangle, kind of. And the two shorter sides are the legs of the right triangle. And C is the hypotenuse, the longer side. And the hypotenuse is always opposite the right angle. So vocabulary, the leg, one of the two shorter sides on a right triangle, hypotenuse, the longer side of a right triangle that is opposite the right angle. You have to be comfortable with these terms because they're going to pop up a lot over the next few years in math for you. Okay, so we can use this understanding of what the Pythagorean theorem is to help us solve problems using right triangles. This is used all the time in careers like construction, architecture, engineering, physics. You'll see some problems where you have to maybe you're measuring because you're building a roof or something, okay? And you have to figure out how to design the roof so that it's tall enough, so that it's big enough, and so that you have enough material to cover the surface of the roof. And to do that, you use Pythagorean theorem. It's everywhere in many careers, more than just what I mentioned here. So the steps are really, really simple. You just write the theorem down, you fill in what you know, and then you solve it for what you don't know. And these same steps are going to be really helpful in our next unit, which is all about 2D and 3D shapes, finding area, perimeter, circumference, volume, etc. Okay, so let's go through an example. We have a lovely triangle here. This is actually an isosceles right triangle. And our two shorter sides, remember those are our A's and our B's. Sorry, it's a really wacky B. And the longer side that is opposite the right angle is C, which is the hypotenuse. And I am going to give you some information. I'm going to say, all right, in this triangle, A equals, let's say, 5. Okay? So our steps that we just wrote down, write the theorem, fill in what we know, solve for what we don't know. Okay, so my theorem is A squared plus B squared equals C squared. Make sure to write this all down. And then I'm going to plug in what I know. Well, I know from this that A is 5. But what about B? Can I figure out what B is? Well, in this case, we have an isosceles triangle. And in an isosceles triangle, the two legs here are going to be equal. So A equals B, they're the same length. So B has to be 5 as well. So I can do this plus 5 squared equals C squared, because I don't know what C is, that's what I'm trying to find out. Then I'm going to solve for what I don't know, solve for the value of C here. So 5 squared is 25, plus 5 squared is 25 equals C squared. I can add these together, 50 equals C squared. And then remember, okay, algebra is all about inverses. The inverse of multiplication is division. The inverse of addition is subtraction. The inverse of a square is a square root. Sorry. So if I take the square root of both of these sides, you can either do it in a calculator and end up with a decimal, and sometimes that's okay. But sometimes the problem is going to want you to give an exact answer. And what that means is taking this square root of 50 and simplifying it. So let's do a quick review of how to simplify the square root of 50. This is from much earlier in the year. You're going to take your number and you're going to split it. What is going on with my pen? You're going to find the prime factorization of your number. So 50 is 25 times 2. 2 is a prime number, so I'll circle it. And then 25 factors to be 5 times 5. Those are both prime numbers, so I'm going to circle those. And I end up with 50 is really 2 times 5 times 5. And it's all under this square root. And do you remember about square roots? What has to happen for you to pull something out of the square root? You have to have two of the same thing under the square root. So I believe I told you guys, one of the 5s murders the other and then runs away to the outside. Does that sound familiar? So your answer here for what the square root of 50 is 5, because that's on the outside, times the square root of 2. Okay, and that's my value for C. All right, hopefully that made a little bit of sense. Let's do one more example. Here we do not have an isosceles triangle. This is a scalene right triangle. The legs of my triangle are A and B. It doesn't matter which one you call A and which one you call B, as long as you're dealing with the legs. So let's call that A and let's call that B. Hypotenuse opposite the right angle is C. And the problem tells you that A equals 4 and C equals 10. How about that? And it wants you to find out what B is. Now this is a little bit different, but don't let it freak you out. Same process. Write down the formula. A squared plus B squared equals C squared. Okay? Plug in what you know. A is 4. 4 squared plus, do I know B? I don't, so I have to leave that as B squared, and then equals C, which is 10, C squared. Sorry guys, my pen's acting kind of funny. All right, and then I simplify. 16 plus B squared equals 10, oh my gosh, 10 times 10 is 100, so it equals 100. I then solve it, subtract 16 from both sides, and I get B squared equals, oh my gosh, 84. Okay, now using the same process, the inverse of a square is a square root. There we go. And I'm left with B equals, let's go ahead and factor 84. And figure out what that can simplify to. So we've got 84. We split it down. Let's say we do 2 and 42. 2 is a prime number, so I'm going to circle it. 42 is 2 and 21. Oh my gosh. 2 and 21. And then 21 is 7 and 3. Okay, I'm going to circle all my prime numbers. And so the prime factorization of 84 is 2 times 2 times 7 times 3. And using our little method for solving square roots, if you have a pair of numbers, one of them murders the other one and then runs away to the outside of the square root. So my final answer is 2 on the outside of the square root sign, and then square root. And then I have to do 7 times 3 because those are left all alone inside the square root, which gives me 21. Final answer there. All right, what I want you to do now is try this reflection. Draw a picture of a right triangle in which the hypotenuse is 5 and one of the legs is 4. Solve for the unknown side length. I want you to type your answer for the side length into Edmodo, and I will check your drawing tomorrow in class. All right? All right, guys, have a good day. I'll see you tomorrow.